Ah, Welcome to all the participants for this webinar on recent advances in environmental engineering. Myself, Professor Vice Sreeramulu, acting as HOD of the Department of Civil Engineering, Annamacahrya Institute of Technology and Sciences. At the first outside, I am thankful to our beloved principal, Dr. S.M.V. Narayan Garu, for giving the opportunity for organizing this webinar on recent advances in environmental engineering. Uh, I had a few 20 years of professional experience. All of you know about the environment, which is surroundings or conditions in which living and non-living exists through chemical or physical and other forces. Others impacts or effects caused by natural hazards or people to environment. This environmental engineering is a sub-discipline of our civil engineering, and we have to see what is the role of environmental engineering. The environmental engineer will use the principles of engineering to develop solutions for protecting people from the adverse effects, environmental problems, works to improve recycling and public health. Let us will see the history behind the environmental engineering, because few or most of the people, they are not aware of the history of environmental engineering. The first environmental engineer is Joseph Hazelgate. The person which he designed the municipal sanitary sewer system in London in the mid 19th century. The organizer can please switch off this. Some voice is coming. Please mute
Yes.
the voice. Then Professor G.D. Agarwal, he is from the India, which is a respected engineer, worked to clean up Ganges rivers and fastest to protect the dam of Bhagirathi River. The next scientist from the civil and environmental engineering background, Mark Edward, he is from Virginia Polytechnic Institute and State University, which is pioneer in detecting the reducing leaks in drinking water supply system. Then afterwards, Joseph Ledbeck, as well as George Pinder, from the same discipline, the experts to take up the legal cases in environmental conditions at Love Canal. We know the tragedy which has happened in Love Canal. So most of the cases will be 19th and 20th century is regulation driven. The ancient civilization, you can see the Indus Valley civilization, which had advanced control over water resources, public water into public baths, water tanks, system. The real river of environmental engineering in modern era started with the scientist, the famous scientist, which a Swiss chemist, he discovered DDT, which is the innovation for controlling of or curing of malaria disease during second half of World War II. Then he was awarded with Nobel Prize for his works. This started a revolution in the environmental engineering field. The modern era started, that is from the 19th century. Up to 19th century, there is very less of this. So the field emerged as a separate academic discipline during 20th century in response to public concern. We'll see the environmental engineering's legacy, the success and ongoing work in various sectors. The first priority may be the water supply. That most affected sector are the wastewater and sanitation, air pollution control, industrial pollution controls. So which clean up by the contaminants which are present in this wastewater things. The 20th century work as a regulation driven, that is framing of the regulations for controlling the pollutants and may take the measures for controlling the sanitation. Whereas 21st century pressures will be challenge driven. As the population increasing, the 21st century pressures are more and more. You can see the total world which can be classified by the group of countries as well as ICRA Samiti. You can have the less developed countries like Africa, Somalia, islands, the developing countries like India, and the developed countries like USA, Singapore, Japan, etc. So this is the classification of various countries across the globe. As we will see, this developed, developing, or less developed, which is based on the our GDP, living conditions, etc. Whereas these developed countries, developing countries, and less developed countries having the problems of environmental pollutions, which may be in the developed countries like air pollution and wastewater sector, as well as hazardous waste. In case of developing countries and less or least developed countries, they had the problem of even supplying of sufficient quality water to the public and in sanitation facilities and lacking of funds to organize this environmental parameters. Now the question is how we will manage all these pollutants which are crossing or emerging in the 21st century. Now let us see here, we are satisfied by saying it is a developed country but not in the pollution aspect it is having. Then what is going to be our aim? Our aim should not be a developed country. Our aim should be a sustainable developed country. What is meant by sustainable developed country? The country which satisfies the present needs of the generation without compromising the future generation requirements and without degradation of environment. I will repeat once again, this sustainable developed country, which should be the vision of every country. It's not a developed country, it should be a sustainable developed country, which means that the country will satisfy the present generation needs and without compromising the needs of future generation and without degradation of the environment. That is very important. So every country should have the vision to become a sustainable developed country. Let us will see what are the pressures in the 21st century in terms of environment. For this, a study committee which is constituted and had the report of pressures, 21st century pressures in the environmental parameters. The committee consists of various professors from the abroad universities as well as the Indian universities, as Indian organizations, and they studied the public welfare and environmental aspects. Finally, they are given a report, the 5 interconnected grand challenges. From the report, I took these grand challenges and induced the recent advances which nullify these grand challenges for all countries. It may be developed or developing or least developed country. Those challenges, we'll see here, the sustainability supply food, water and energy. This is the one grand challenge we are facing. Second one is the curb climate change and adapt to its impacts. Third grand challenge is design a failure without pollution and waste. Create efficient, healthy and resilient cities. And last grand challenge is foster informed decision and actions. So for these grand challenges, the advances are developed and developing in the research. That also I'm going to share with you. So before going that, what are the skills of an environmental engineering should bring? It should have a broad understanding of Earth systems, experience working with aligned science, and holistic thinking, which consists of the life cycle analysis and similar tools. The first grand challenge, which is having the sustainability supply food, water, and energy. Nearly 800 million people are undernourished across the globe. The 844 million without safe drinking water, 2.3 billion without sanitation. This is what the present scenario. As the 20th century working as a regulations which are not going to satisfy the needs of 21st century pressures. To overcome these pressures, we have to go for the advanced techniques in the environmental engineering field. The sustainable feeding a growing population, the increasing yields without impacts on water, soil, and climate. To monitor or to regularize this, we have to utilize the sensor technology, innovations in farming and aquaculture. And the major thing is we are wasting the 30 to 40% of the food. It is wasting. We are wasting this food. When you utilize this food for the 30-40% of the population across the globe, the food problem will solve. Similarly, you can use protective films, consuming education. Changing diets should also feed 30% more people. No person should be hungry. To overcome water scarcity, this is the problem which is facing in least developed countries as well as developing countries. We have to create new water supplies, low-cost technologies, go for reliable reuse, desalination. You can have these options while utilizing the water effectively and equally. We had the increased water use efficiency, maybe the changing of the process and technology, and many places we are not having the water for even toilets and bathrooms. So you can go for waterless toilets so that it can overcome the problem of water scarcity. And changing the behavior, don't waste the water. You can change your behavior and it can be reduce the consumption of water. Redesigning and revitalizing distribution systems. There are many problems in distribution system. So you can adopt the intermittent water supply system or continuous water supply system. There are the cases of two systems having their own advantages and disadvantages. So we'll see how those are in advances in portable water supply engineering. In advances in portable water supply engineering, the ATW, which is anytime water, like our ATMs, which is 24/7 water supply system, which is a continuous water supply system. When adequate quantity of water is available, we can go for 24/7 water supply system instead of intermittent, that is 1 or 2 hour supply system. In intermittent water supply system, there is a chance of pollution when non-supply periods. The wastewater line or sewer line which is passing along the water distribution line during non-supply period of water supply, the sewage which is leaking from the pipelines and can be entered into the water pipelines. Once the water supply started in the water supply pipelines, this pollution or contaminants which is mixing with the water water, and it will travel along with the water pipeline and got polluted or contaminated. So you can go for the continuous water supply system, which is the good one when adequate quantity of water is available. Even you can go for automation and SCADA application. The supervisory control and data acquisition and automation can minimize the wastage of water and monitoring very easily, as well as 100% foolproof. You can control the water supply from different places by sitting in the SCADA room. This is the automation which is advanced in portable water supply engineering system monitoring side. One more thing is the leak detection sensor equipment. 30 to 40% water is wasting in the water supply lines. Once the water treatment happened, the treated water which is distributing to the consumer, there is a transmission line, there is a distribution line. When passing from several kilometers from the water treatment plant, this water is leaking through pipes. To arrest as well as to identify these leakages, you can use the latest technologies of leak detection equipments, noise sensors, even pressure wave sensors, similar equipments. Once you identify the detection, you can take the control measures and you can arrest the waste of water. Once this water is arrested, so far 20 to 30% of water which will save, that is treated water, very valuable water that can be asset to the municipalities as well as to the government, which can be utilized by the consumers. Next technology which can be there in advances, that is rainwater harvesting techniques. We know the rainwater harvesting techniques. Soak pits generally we will use to collect the rainwater from the rooftops as well as from the streets. These rainwater techniques, one of the advantages is you can construct the soak pits along the national highways. So much of water you can harvest it in the banks of the aquifers. Even the important thing is analyzing water samples, which is a very much necessary to have the quality of water. With analyzing water samples, we are taking online. That is, you can use in the laboratories and you are going to test. Whereas now the advances has come to take up online or on field. Directly you can go for and take the samples and can analyze various parameters of the water samples. Turbidity, acidity. Online, you take the you can assess the water is good or polluted and have the standards with the WHO. One more technology for desalination, because the desalination is the future source. As we know, 70% of water which is present in the oceans, more than 70%. How can we utilize this saline water? The abundant source of this water can be used by going for nanofiltration as well as desalination plants and can be converted into the potable water. The thing behind this, for us now, you can say the RO water which is available 20 rupees per liter, whereas the municipal water we are getting just 1 paise per liter. Whereas the desalinized water, it will cost 80 to 100 rupees per liter for conversion of this. The research should be focused on to reduce the price for desalination techniques. So this is one of the area to go for research and improve some more advancements to reduce the price to 20 rupees or even 10 rupees per liter. We had the desalination plants in Chennai, in India, as well as we had the desalination plants more in the abroad. So this is the surface water treatment plant. You can also atomize by using the pressure gauges and sensor techniques, so that there is less man intervention for controlling this, which is automatically controlled by SCADA lab. Supplying sustainable energy to all. Now the slogan for sustainable energy is to go for low carbon energy sources to reduce the pollution and other aspects. Go for conduct of life cycle assessment, develop emerging sources, which is anaerobic digesters, and even go for getting energy to remote areas by using sustainable microgrids. Nothing but you can use solar power, wind power, which is naturally available, and it is a sustainable source. The grand challenge which we can address climate change and adapt to its impacts. You can observe in this graph from the 20th century to 21st century, temperatures are varying and the sea levels are rising up to 1.2 feet. But the infrastructure is optimized for 20th century climate only. But now we are having temperatures in higher ranges in the 21st century, which the sea level could rise as much as 1.2 feet more by 2050, which will cause the climate change and global warming conditions, extreme weather, heavier rain in some regions, as well as more droughts in other regions. This is the effect due to the climate change, which also impacts to water management, ecosystems, biodiversity, agriculture, etc., and enters to human health also. Here, the advances needed to curb climate change are use energy more efficiently, switch to low carbon energy sources. We have to make advances to make renewables more cost effective, advanced nuclear to improve safety, climate intervention stages. You have the strategy of capture carbon. You can go for develop strategies and technologies, strengthen disaster resilience, increase resilience of critical infrastructure, adapt to coastal flooding, and mitigate and respond to health threats. So this will benefits or potential impacts, cost and future risks. Yeah, you can see the reducing rate and magnitude of climate change, which the sharp reduction in greenhouse gas emissions. It will be limiting warming to 1.5 degrees centigrade required, the dramatic reduction in carbon dioxide, active removal of carbon dioxide. You can have the power transportation, buildings, industries, electricity generated with low carbon emissions. The grand challenge 3, we have the design a future without pollution or waste. In this context, we have the industrial revolution linear model, take, make, waste. 94% materials extracted from the earth and the waste versus 6% that end up in a product. There you can have the controlling of waste. Even diseases driven by pollution accounted for 1 in every 6 deaths. You have the legacy pollution challenges. It may be the natural resource extraction, production and consumption, waste and pollution. So to eliminate the concept of waste, waste is a human construct. If you remove the pollution, you have the gold. That is what we want. Designing products, process and systems that put unutilized materials and energy to valuable uses. The opportunities to recover valuable form are from municipal waste or wastewater, agriculture waste, carbon capture. The advances needed to identify resources in waste streams. You have the access costs, market and impacts, design process to enhance the recovery. You can see the advances in polluted water management or wastewater engineering. About the polluted water, 99.9% water, to remove those pollutants, then the water will be there for 100%. We have to go for analyzing polluted water sample. You have the latest technologies for analyzing the polluted water samples in terms of conventional parameters like pH stability, BOD, COD, and even you can go for the trace elements analysis by using atomic absorption spectrophotometers. And you had the sewage system, which should be completely by the sewer lines. At present, many of our cities are lined up with poor sanitation system, like septic tanks. Even you can go for the 1 or 2 lines like that. But the conversion of these to the modern sewer line system, which will take up the wastewater sample from the household and will be taken to treatment usually. One more is advance is the vacuum sewers. Vacuum sewers is the one of the advances in wastewater engineering or polluted water engineering, which can be used in the siphon conditions. Wherever the undulations or higher altitudes, which will be there, you can go for these vacuum sewers. You can also using trenchless technology for going sewage system. So the lines, that is street width, wherever less than 0.6 meters, you have to go for the trenchless technology, where the building foundations will not disrupt and the sewer lines can be laid, and the sewage will be taken and will be treated in the sewage treatment plants. One more advancement in sewage treatment plants is decentralized STPs. In general, the sewage treatment plants we are using, or we are taking the domestic sewage through the laterals and interceptors and finally the trunk sewers. So all these sewage from the household or building to the streets and next line is to the roads and taken up to the treatment plant. The laterals which are using for collection of sewage samples from the household and intermittent sewers are using to take up to the roads or highways, and again we are utilizing the trunk sewers to take up the wastewater up to the treatment plant, where we are going to take up the treatment plant. It almost 5 to 25 kilometers or even 50 kilometers away from the source. So it's a long process. The sewage should flow along this number of kilometers. It will take even putrefaction process. To avoid this, we can go for the decentralized STPs, which may be 4 to 5 colonies. You can go for a decentralized STP with reuse and recycle option. That is a small sewage treatment plants. You can design, may goes for 0.5 mld to, you can go for the up to 1 or 2 mld. Even our educational institutes, you can design this type of decentralized sewage treatment plants. So in each educational institute, you can go for one decentralized sewage treatment plant with an option of reuse and recycle, so that the sewage can be effectively treated by using option and can be treated. Even for our institute, we are designed for this, and it is going to be implemented and operated. We have to take care for this type of drinking water and sewage treatment facilities for every education institutes, because of we had large gathering of students. One more advancement, as you familiarly known, that is upflow anaerobic sludge blanket. This fluidized bed reactor or upflow anaerobic sludge blanket reactor, which is an advancement in the anaerobic digestion process. It is a continuously operated system and give the 70 to 80% treatment efficiency in terms of wastewater. One more advancement in the polluted water or wastewater engineering is utilizing the artificial intelligence technology. This artificial intelligence technology can be utilized for detecting the leakages, even treatment problems in the both water supply and sewage aspects. This is also with advancement in the 21st century. The next one of the environmental pollution is solid waste. How we can manage this solid waste? You had the 5 R's techniques, that is reject, reduce, reuse, recycle, and recovery technology. Initially, the solid waste can be rejected. Not use the waste or solid waste type of materials. If you are not utilizing, you won't get any waste. Even reduce, utilize less solid waste materials for raw source. Reuse technology, even though utilizing a small percentage of solid waste, it can be go for reuse. Don't throw it as a waste material into the garbage or dustbins. You can reuse as the newspapers which are using today, tomorrow it may be waste, but if you given to the vendors, they can recycle or go for reuse and recovery technologies. Earlier we are having the waste from the solid waste, it is only the waste, but in the 21st century, whatever the waste available in the solid waste or in other form, it is not a waste. It having a process of technology of reuse, recovery, recycle, and converted as a gold. In the abroad countries, the whatever the waste which is available is not treating as a waste material. It is using it is treating it as a gold material. When you find the waste, your research application will be enabled and can be converted into the valuable material. There are scientific landfills for managing of solid waste that generally we saw in our regular curriculum. The landfills which are designed a single liner landfill which can be there. The trench can be trapezoidal shape that can be dug, and the galvanized sheet can be spread in the landfill, and the PVC pipelines are spread along laterally which have the pores. You can spread the solid waste and then you can make a soil liner. Then again 1 to 2 meters you can pour the solid waste and can be rolled by the 10 ton or 20-ton roller. Effectively, you can make so many layers and to fill up the solid waste landfill. Once this landfill is covered, the process which is happening is whatever the solid waste you are dumped will biodegrade. All the waste is biodegrade, which the liquid is generated, and that liquid will be transferred into the pores of the PVC pipelines, which is known as leachate, as we know. This leachate can be taken out and can be treated in the treatment plants, and the converted biodegradable solid waste can compost here and become manure, and the gases will be generated, which composition of methane, carbon dioxide, etc. The gas of this can be utilized for our cooking purpose, or we can use for hybrid power or hybrid automobiles transportation. In the aspects of solid waste management, we can also use the application of remote sensing and GIS. The application of remote sensing and GIS, you can identify the landfill sites in the city and can be disposed of the solid waste in that area. With the available satellite maps, you can identify where the free land or barren land is available. There, you can take the options of landfill criteria. Even by using GIS technology, you can track the solid waste trucks can be monitored and effectively you can transport the solid waste. Even you can use the robotics in solid waste as well as hazardous waste management also, because the man intervention is difficult to enter few of the places which having more order in the solid waste uh, transfer sites. Even one of the solid waste management technique is conversion of electricity. This solid waste can be converted into RDF plants. The RDF pellets will be generated, and then the electricity conversion will be taken place, which having this plant in our in Andhra Pradesh, Vijayawada, and Telangana, Hyderabad. Two plants are there. Almost the power is generated in these two areas by using the municipal solid waste only. You have the hazardous waste management and special waste management. In the aspect of biomedical waste, it is an emerging area because number of hospitals are increasing day by day. You have to collect this waste separately. Do not club with the solid waste. This biomedical waste can be taken separately in 6 bin systems: red, yellow, white, black, green. So all the waste which is available can be segregated based upon these bins and can be taken out. And the BMWT, that is biomedical waste treatment facility, is separately to be constructed and can be treated by using the technology. Even your hazardous waste management, you have separate solid waste management treatment and hazardous waste management treatment facility. The hazardous waste management consists of TSDF sites, which is transport, storage, disposal facility, or treat application or usage of robotics. You have the robotics system which can be utilized in hazardous waste due to the difficulty of man intervention. You can apply the robotics and sensor technology, which will identify the organic matter, inorganic matter, even the hazardous matter can be by shape, surface texture, and other sensors, so that this will be segregated and can be treated properly. Even though the special waste also can be treated by using these techniques, that is e-waste, electronic waste, and nuclear waste. These also can be treated, can be taken out and dumped into the mid of the sea, which can be shielded with the galvanized sheets or plastic sheets. These are the few more techniques of managing the solid waste. We have the collection and transport system through the underground collection, web-based GIS technology, waste monitoring technology, global system of mobile application, compact garbage collection trucks, segregation, multi-compartment bins, optical sorting, automatic bottle sorting system, segregation of recycling, that is the one of the technology, de-inking technology for paper recycling, that is biodegradable and degradable plastics, correct manufacturing. So it is taking list of processing, saving technology, vermicomposting. Even we can go for energy recovery, which is having the thermal conversion, advanced thermal treatment technology, pyrolysis, gasification, plasma pyrolysis, refuse derived fuel, That is the conversion of the solid waste to RDF, fluidized bed technology, dry anaerobic composting. Finally, the disposal can be taken place through the sanitary landfill, bioreactor technology, landfill gas recovery technology, micro turbine technology, fuel cell technology. These are the few advances for taking of solid waste management technique. Please mute yourself, the participants. The solid waste management also taken the new 4-bin system. Earlier we had the stationary container system as well as mobile container system, but based upon the this type of reuse or paper waste can be taken separately, glass waste can be taken separately, that is the inorganic matter, and the organic matter like vegetables, etc., can be taken separately. The plastic material which can be taken separately. As you are already aware of, the plastic is a 21st century problem. This is not easily digestible. That's why we are utilizing in the roads, utilization of plastic waste in the roads, that is plastic roads, and even crumb rubber can be utilized for the construction of roads. You can see here, there are various techniques can be utilized for solid waste management, starting with minor collections, major collection points. We had the minor collection points, that is roadside dustbins, major collection points, temples, public places, etc. Even from the municipal households, door-to-door collection, street sweeping can be transferred to bins made concrete or masonry or movable container system, taken to hand-cast trials, community bins, tripper tractor, transportation, auto rickshaw. Like this we are transporting. Even the movable container system, container itself can be taken and transported up to the disposal site. The one more pollution is air quality management cycle. Air pollution is the main problem in the developed countries. How we can manage this air pollution? We can have the emission reductions, develop control strategies, scientific research, implement programs, undertake ongoing evaluation, and finally establish the goals. It is a continuous cycle. So these are the core expertise of air pollution management. You can have the aerosol measurements, process-specific exposure, process-specific emission rates, emission control efficiency, inhalation dose rates, exposure modeling, emission control, efficacy labor library, dose and dose response, emission library. You can have the risk assessment, risk control. This can be having monitored with the our automation system. So for controlling air pollution, you had the usage of equipments in industries. In the older time, you are using the gravitational settling chambers. Right now, you are using the electrostatic precipitators, fabric filters, gaseous filters, beds, etc. The best method for air pollution control is go for green, that is afforestation, plantation technology, which is a scientific technology which can be used. Each one plant one, you can have the plantation to be taken individual responsibility. You have to plant one tree at least on your birthday. each individual or citizen can take. This is the responsibility as well as taken it as guardianship of that particular plant. Then only we can solve many more problems. Even whatever the advances we are inventing as engineering side or scientist aspects, those are not sufficient for restoring the natural environment. Natural environment, when we want to develop, we have to go for naturally. Those are green plantation. So designed to reduce or eliminate pollution and waste, you can develop a circular economy that eliminates pollution and waste using. You had the life cycle and systems thinking, green chemistry and engineering. Just anticipate consequences, what are happening in this pollution and waste control. Avoid unintended consequences. The challenge 4 we had, create efficient, healthy and resilient cities. This context can be addressed. The future is urban only. Day by day, the living lifestyle is changing. Everyone is going for modern lifestyle, modern habits, modern culture, modern education. Hence, the future is urban and cities, which will have 2 billion more people by 2050. Number of mega cities are expected more than 10 millions. The aging urban infrastructure presents opportunities to improve quality of life. To address other challenges such as climate change, adaptation, pollution, water supply and waste, how we will manage for this growing population and growing cities, that is going to be the challenge. So to solve this problem, we have to go for creating efficient cities, re-envision urban architecture, transform existing infrastructure in urban form, create alternative for energy and water efficiency and other benefits. The best solution for this is advanced smart cities, which embed sensor to monitor traffic, water, energy use, and use of trash bins, etc. Use data to inform decision making. These are going to be solve the problems of the present or expected problem. Creating health cities also a solution. Design equitable access to recreation, green space, improve indoor and outdoor air quality, reduce water pollution, prevent, detect, and mitigate the spread of infectious disease, ensure reliable provision of clean water and manage waste. That will be the best solution to create the health city. Creating resilient cities which can be assessed vulnerabilities like sea level rise, heat island effects, develop systems that have multiple benefits like your flood control or POX, manage, build resilient infrastructure. The ultimate challenge for environmental engineering is preparing the field to address a new feature. The evolving practice which we had, cultivate a more diverse workforce from K-12 through graduate training, enhance stakeholder engagement, use tools to help stakeholders understand the consequences of decision alternatives. This is will this evolving education will take up to solve the future problems. The enhancing the curriculum is comprising of build emphasis on complex systems and social science. Keep pace with global challenges, build essential skills among graduates, which consists of collaboration, critical thinking, real world problem solving, effective communication, which will solve the major problems in future. The possible strategies for improving education, which increases reliance on graduate training to allow more breadth in undergraduate training, create practice and service-based models instead of theoretical. And you can introduce the scholar programs in environmental engineering like bachelor engineering. This is the best solution which of 21st century problems. The advances can be evolved through research. Universities should promote and reward interdisciplinary work, enhance interdisciplinary mentoring. Research funding institutes should facilitate effective collaboration, early career awards on interdisciplinary themes, expand interdisciplinary research support, develop engineering research centers around grand challenges. Few research which is taken by the scholars which are reviewing of chemical coagulation or flocculation technologies for removal of color from textile wastewater from IIT Bhubaneswar, cyanide in industrial wastewaters and removal in IITs are taking place, electrocoagulation for removal of phosphates from aqueous solution, application of ultrasonication and hybrid bioreactor of synthetic textile wastewater, even geotechnical characterization of expansion soil and utilization of space to control its swelling and shrinkage behavior. Here, the geo-environmental engineering is one of the emerging area for controlling of this pollution in the soil. Introduction to sustainability and sustainable development from the IIT scholars and abroad universities students. Challenge 5 is informed decisions and actions. We had the context of challenges. Solutions to the grand challenge required the 21st century, which require widespread adoption. Action will only come about if society is well informed about how the environment affects human well-being. It is not only the government responsibility, it is the responsibility of every citizen to take up this environment education. Experts and stakeholders act in partnership to identify the problems or solutions. It is not the scientist only find the solution. Every individual can get the problem as well as solution to solve it. So here the linking environmental social impacts, identify and quantify the full consequences of actions. How do changes in policy and technology shape behavior and affect environment? How does environmental change affect human prosperity? How to measure these effects? Increase diversity in the engineering community. Develop and use decision support systems. This environment can be linked with the latest technology of decision support system automation, SCADA. Engaging with stakeholders. Understand community context for challenges and solutions. Understand broader economic, social, institutional factors. create open dialogue with them, increase diversity in the engineering community. It's also informing to the policy solutions. Strategies includes providing information, educate the public, changing the decision context, creating incentives for making sustainable planetation or sustainable smart cities, setting rules and regulations. Rules can be set and effectively regulated and monitored. So here we can go for the ultimate solution is planting of trees, make the green instead of synthetic trees. Synthetic trees are artificial trees and advancement in developed countries, but that is not a solution. That is a engineering dimension or engineering invention. This can be utilized where the plants are not taken to grow, but not in all places. Synthetic trees or artificial trees is not the solution of environmental problems or environmental pollution. The solution is afforestation or go for green, take up the plants and take its guardianship and make green in Andhra, India, as well as world. So the slogan at end is Green Andhra, Green India, Green World. Thank you all.